Hello everybody and welcome back to the Parkinson's Disease Education Podcast. Now, recently a subscriber asked me a very interesting question. They wondered whether there might be some connection between copper deficiency and Parkinson's disease. Specifically, they mentioned a protein called Ceruloplasmin. When I first saw the question, I kind of thought, I don't know if there's going to be much to this. But upon further research, there actually is a pretty fascinating connection between copper and Parkinson's disease. Now, it's not quite as simple as just saying people with Parkinson's disease are copper deficient. As a matter of fact, I think it's much more interesting than that. So today in this episode, we're going to take a look at what we actually know, and just as importantly, what we don't know about the connection between copper and Parkinson's. Let's roll the intro, we'll talk more on the other side. Welcome to the Parkinson's Disease Education Show, where we demystify the disease and empower you as the person with Parkinson's disease to reach your true potential. The content contained on this show is for informational purposes only and is not meant to be a replacement for information or advice that you receive from your in-person medical or therapy professionals. If you haven't already, I hope you'll consider subscribing, and for an even more personalized experience, please ask us about our memberships. Now, without further ado, let's start the show. So this is not likely to be the first and last episode that we do here on the channel or on the podcast in terms of copper, but I wanted to go into a little bit of why we even care about copper in terms of this neurobiology and neuroscience, and we'll go from there. First of all, it's important to know that copper in the body is a trace element or a trace mineral, meaning that it really accounts for less than 1% of the entire body mass. Now, that doesn't mean it's not important. Copper is an essential trace element, and it's crucial because copper actually activates many enzymes throughout the body. In addition to activating several important enzymes, it also is important in energy production, nervous system function, and connective tissue formation. So there's a lot of different functions involving copper in the body, even though it is a trace amount found in the body at any given time, compared to other substances like oxygen and hydrogen and so forth. Copper is definitely not something we want to eliminate. Obviously, you don't want an excess of something in the body. That could be a negative thing. But copper is one of the substances where the balance matters, and too little can actually cause problems. Now, too much free copper, throughout the blood serum, for example, could actually cause problems and damage to the body, because copper could actually contribute to oxidative stress throughout the body if it's found unbound throughout the body. Our human body actually is built to withstand copper as an element in the body. In other words, it's meant to control it and control how much is bound versus unbound in the body. And for that, we have the protein ceruloplasmin, and that's produced by the liver. Copper is mainly found in our bloodstream bound with ceruloplasmin. Now, where this gets particularly interesting in relation to Parkinson's disease is that ceruloplasmin actually acts as what's called a peroxidase. So in simple terms, that basically is an enzyme that helps to convert iron to one chemical form or another throughout the body in order for iron to be properly transported and handled throughout the body. And that brings us to one finding that's particularly interesting pertaining to Parkinson's, is that there's excess iron accumulation in the Substantia nigra in the brain. So interestingly enough, the Substantia nigra is actually a relatively iron-rich area of the brain. Now, in Parkinson's disease, numerous studies have actually indicated that iron can become further elevated in the Substantia nigra in particular in Parkinson's disease. So the reason that matters is because iron can also contribute to oxidative stress because of reactive oxygen species. In other words, iron can be directly involved in those reactions that create reactive oxygen species. If you remember from previous episodes, ROS is produced primarily by mitochondria in these cells. To begin with, and we mentioned this previously as well a couple years back, and in some of the clips I've published recently, Substantia nigra, part of the brain, that midbrain area, is a high traffic area, and it's a metabolically demanding environment. So there's already a lot of stress there, naturally speaking. So if there's any accumulation of abnormal elements, or I should say the normal elements at abnormal levels, that can actually contribute even more to the possibility of oxidative stress. But just to go into that for just a moment, why is it such a high traffic area? Well, we've got dopamine metabolism that's going on. Mitochondria are working hard, producing ATP, other cell signaling jobs, and you've got neuromelanin, which incidentally involves copper directly. You've also got high oxidative stress, again, because of the high traffic in the area, also potentially increased iron. So researchers have been asking, why is iron actually accumulating there? One possible piece of that puzzle, it turns out, is ceruloplasmin. So if ceruloplasmin concentration or activity is reduced, that could result in iron accumulation in areas where it's not supposed to be. So there actually is current research that's showing a potential relationship between lower ceruloplasmin and abnormal iron accumulation in the brain in Parkinson's disease specifically. An MRI study in 2021 found that Parkinson's patients that had lower serum levels of ceruloplasmin also had more widespread patterns of iron accumulation throughout the brain. So potentially there's an interesting pathway possibly at play here. This is not research proven, but it is an interesting concept to think about in terms of what leads to the next thing. So copper leads to formation of ceruloplasmin because that's how the body tends to package it. That affects iron handling, which can in turn affect iron accumulation. That can lead to more oxidative stress. That in turn can lead to potential neuronal injury. This isn't necessarily talking about causative factors in developing Parkinson's, but more looking into a biologically plausible connection between the two things. So this is where things start to get really interesting. There was a meta-analysis in 2020 that looked at studies measuring copper and iron in Parkinson's disease, and the researchers found that copper was significantly lower in the Substantia nigra of persons with Parkinson's disease. At the same time, iron levels were higher. There's actually even newer evidence available as of this recording, 2026. There's a systematic review and meta-analysis published this year that looked at studies involving copper, ceruloplasmin, and several other metals in Parkinson's disease. And what the researchers found was that there were significantly decreased copper concentrations in the Substantia nigra and other brain regions. They also found decreased levels of ceruloplasmin in folks with Parkinson's. In addition, there was a correlation of having lower serum levels of copper. One way or the other, there's definitely some kind of connection between Parkinson's disease and copper biology throughout the body. Now, we got to take a pause here and slow down. And I want to reiterate, we're not trying to directly, in this episode, relate Parkinson's to copper deficiency. That's not the case. There's definitely not evidence at this moment to make that connection. Remember, correlation does not equal causation. There has to be some kind of, at least in published scientific journals, there has to be some kind of empirical evidence to make an absolute statement that that's the case. But there are several possibilities that do arise from this information. Number one, maybe low copper contributes to the disease. Number two, maybe Parkinson's itself disrupts copper metabolism for one reason or the other. Number three, maybe both are happening simultaneously. Or perhaps like other things we've found in Parkinson's disease, like oxidative stress, inflammation, abnormal protein aggregation, mitochondria, iron changes, all that kind of thing. Maybe it's copper abnormalities are just one of the growing list of things that are a component of much larger changes in the metabolism of the entire body. We simply don't have enough evidence in current medical science to say one way or the other. Then there's the Alpha-Synuclein Connection, and that's honestly where I think this gets even more particularly interesting. Copper can also interact directly with alpha-synuclein. Now, I'm not going to repeat all the information about alpha-synuclein because that's been talked about numerous times on the channel and the podcast, but it's an abnormal protein that causes much of the motor and non-motor symptoms of Parkinson's, as well as Lewy body dementia, development of Lewy bodies. So apparently studies have shown that alpha-synuclein can be influenced by copper in terms of how the alpha-synuclein molecules are structured. Not only that, but it can affect where they're located and how they aggregate. In some experimental systems, they've even found copper to accelerate the aggregation of alpha-synuclein. So we have yet another pathway that's possible here. You've got copper that can interact in a specific way with alpha-synuclein, and that can result in altered folding of the protein and hence potential toxicity. Again, I want to emphasize this is potential information or potential connections. They haven't been proven. That being said, it does mean that copper is potentially biologically capable of interacting with one of the main key players in Parkinson's disease, that being alpha-synuclein. So if copper is deficient, at least in parts of the brain, should we just supplement copper? Not necessarily. The issue here is not necessarily that there's not enough copper in the body, because as we said, there may be potentially lower serum levels of copper in the body. Copper is not found in free form in the brain. In other words, if it's in the serum, it's likely either bound to ceruloplasmin or there's some copper ions floating around. So the root of the issue is copper, a lack of copper homeostasis, or how it's handled biologically. So that's really the goal, is to kind of bring that back into balance, is how the body handles copper, and that could be through the ceruloplasmin particularly. Now, that's not to say an overall copper deficiency throughout the body couldn't cause neurological issues. In fact, there's a condition called myeloneuropathy, which is where prolonged or severe copper deficiency can actually cause issues such as ataxia, gait problems, weakness, or other neurological abnormalities, which could mimic a form of Parkinsonism. Now, and copper deficiency is a potentially treatable condition, but again, it doesn't mean it's linked with PD directly. Now, copper deficiency is also connected with Wilson's disease, which can also mimic some Parkinsonian-like symptoms. So let's summarize this into basically the key points we need to take away from this episode. First, copper appears to be altered in Parkinson's disease. We can definitely say that. And specifically, there's lower copper levels found in the Substantia nigra, which is the key area of the brain affected by Parkinson's. Second, ceruloplasmin may also be an important part of the story. It is a copper-containing protein, therefore it does play a major role in iron metabolism, which is also something else that's altered in Parkinson's. Which brings us to point number 3. Iron accumulation is an important feature of PD, particularly in the Substantia nigra, again, that same area of the brain. There definitely appears to be, at least, a relationship between dysfunction of ceruloplasmin and abnormal handling of iron in the body. Fourth, copper can interact directly with alpha-synuclein, and thus far the research is experimental, but it does suggest that copper can influence alpha-synuclein aggregation and toxicity. Lastly, number 5, we don't yet know whether copper abnormalities are a cause of Parkinson's, simply a coincidence that comes along with it, or one piece of a much larger disease process throughout the body. So should one get tested for copper or ceruloplasmin levels? Maybe. There's not really enough of a push to say that that's truly something that should be monitored over time. And again, a normal copper level in the blood serum does not necessarily reflect what's going on in the brain. Based on the current evidence, copper supplementation is likely not going to be helpful either, because again, if you're looking at serum levels, you might increase serum levels of copper, but you're not necessarily going to do anything to impact the amount of copper, or therefore iron, found in the substantia nigra of the brain. Overall, it's just important to remember that copper metabolism is something that appears to be abnormal in Parkinson's disease, but we don't know what the direct correlation or connection is at this point, just that it's there. The big picture here is that Parkinson's biology is way more complicated than just one deficiency like copper. Now, while it's important to acknowledge it and discuss it in this episode, it definitely does not necessarily help to narrow things down to one thing, being a cause or being a contributing factor. Is it helpful to know? Definitely. But there's so much more to it than that. We've got dopamine toxicity as a potential, where the concept of dopamine actually being stored in the dopamine producing neurons, and that's what's actually resulting in cell death. Could that be related to copper levels? Not sure. Possibly. One way or the other, though, dopamine toxicity is definitely a prominent subject that is taking on some new theories in how we deal with Parkinson's disease. If you haven't seen my previous episode on dopamine toxicity and my interview with Dr. Jonathan Sattner-Bernstein on his medication that they're doing research on, definitely check those out. We also see all these other abnormalities, the mitochondria and the cells of the dopamine-producing cells, alpha-synuclein aggregation, various forms of oxidative stress, inflammation throughout the body, and of course now we've addressed the iron, the copper, even calcium levels, the function of lysosomes within the neurons in the brain, protein clearance from the body, and many other systems that are impaired with Parkinson's. So none of these things independently operate. They're all connected. And there's also numerous gene mutations that have been linked with Parkinson's disease. There's LRRK2, there's Parkin, there's PINK1, just to name a few. So just to try to wrap all this up, because there is a lot to think about here, I do want to thank the subscriber for bringing this up and leading us down this rabbit hole, because it's definitely something worth looking into. So please leave it in the comments if you'd like me to dig into this deeper. I'd like to talk a little bit more about neuromelanin potentially in the future and that connection with Parkinson's. maybe we can look into copper peptides and see if that might have some kind of improvement in the body or in the brain. We might even look into the various enzymes that copper can influence, particularly as it relates to Parkinson's disease. And some of them, I can tell you already from not even talking about it in this episode, they actually relate directly to dopamine or dopaminergic pathways. At least one of them does. So let me know about all that. I'd love to do some more episodes that might be able to deep dive into one of those segues. So please let me know in the comments what you'd like to hear about. Thanks as always for watching and listening. If you like this episode, please like the episode on YouTube, share it with everybody that you can if you think they'll benefit from this information. And if you're listening in podcast form, please consider following the podcast. As always, be empowered. I'll catch you in the next episode.